For homework 3, we're going to look at two problems. We're going to look at problem 7, when you throw a ball up to a height on Earth and you ask how high will it go on Mars. And we're going to look at problem 10 with the Honda Civic. First, let's start by reviewing the equations that we have to deal with. Distance traveled along a horizontal direction. We have the distance x, the acceleration a, the time t squared, right, plus the velocity, the initial velocity in the x direction v naught, and the time, and the initial position x naught. And as we talked about before, usually x naught is going to end up being 0. And then velocity. Velocity is going to be v naught plus at, right? Initial velocity plus acceleration times time. We have another equation, the net force. Force is mass times acceleration. That's just Newton's second law. And also from Newton, the weight of an object is just its mass times the acceleration of gravity g, which for us in this problem is 9.8, or in the problem below will be 9.8. The velocity, the acceleration of gravity on Mars is, let me go take a look at that. On Mars, oh, we'll have to look that up. Where did I give that to you? Here you go. Acceleration on Mars, 3.71. All right. So 9.81 on Earth, 3.71 on Mars, meters per second squared. If we're throwing something vertically, just straight up and down, its position y, i.e. the height it's at, is minus 1/2 gt squared. So g is the acceleration of gravity, t is time, plus v naught t. V naught's the initial velocity you throw it up with, t again is time, plus y naught, the initial position you started throwing it up from. And again, usually that's going to be 0 in our problems. Vertical velocity in the gravitational field is v equals minus gt plus v naught. And if you notice, vertical motion and horizontal motion, they're the same equations. It's just a equals minus g. All right? If you just take a and make it minus g, this equation becomes this equation. And if you take a and make it minus g, this equation becomes this equation. We're also going to need, because it was given in a problem, we're going to need the height, that the velocity needed to reach a particular height. The maximum height it's going to go to is v naught is the square root of 2gh. And that's what we need for problem 7. So we're going to start with problem 7. And there will be a separate video for problem 10. Alright, so problem 7, suppose you throw a ball to a height of 14.7 meters on Earth. So that tells us right away, height 14.74 meters on Earth. G equals 9.81 meters per second squared. Right? We're given both of those things in the first sentence. If you throw the ball just as hard on Mars, how high will it go? Well, the question is, how hard would we throw it on Earth? And how do we get that? Well, we're going to get that, and I'm going to put v naught is square root of, right, 2 times 14.74 meters times 9.81 meters per second squared. All that ends up being meters per second once you take the square root, right? That's going to be meters per second. So let's go calculate that real quick. Equals the square root of 2 times 14.74 times 9.81. And we're going to get 17.01. We'll just call it 17. 17 meters per second. All right, that's how hard we threw it on Earth. So now we turn to Mars. We're going to throw it just as hard, but how high does it go? Right? Well, we don't know that. We have the same equation, v naught equals the square root of 2gh, so we're going to have to square both sides. All right, v naught squared equals 2gh, gh. Our g is now different. I'll even put in here Mars, right, h. And we have to solve for what? We have to solve for h. The v naught is the same because we're throwing it just as hard. We're throwing it with the same velocity. So let's solve for h. H equals v naught squared over 2g Mars. Right? So let's stick in the numbers. Oh, let's stick in the numbers. So V naught, we got 17 meters per second squared divided by 2 times 3.71 meters per second squared, all right, equals. And the units in the end are going to come out to be meters because we got meters squared over second squared divided by meters per second squared. So it's going to end up being meters. Let's calculate this real quick. So equals 17 squared divided by 2 times 3.71. Right? And I get 38.95. We'll call it 39. 38.95 meters. And that's problem 7.